given the graph of the function f, estimate f of 2, find x such that f of x equal 2, and find the domain and the range of the function. Part A, estimate f of 2 is similar to evaluate f of 2. If a formula is given, we just simply plug in x equal 2 into x. In this case, a formula is not given. So to evaluate f of 2, that is the value of the function, how high it is when x equal 2. So we locate x equal 2 and we go to the functions. When we go to the function, to identify the functional value is to find how high the function is. We can only go up or down vertically. After we identify x equal 2, we go to the function. In this case, we would go down. And then to read off the y value, which is f of 2, we would go to the y-axis. And so it looks like f of 2 is approximately a quarter, and it is below the x-axis, and so f of 2 is negative 1/4. This is only an estimate. Part B, find x such that f of x equal 2. Now in this case, we do not have x, but what it is that we have y equals 2, and we need to find out what x is. We would go to y equals 2 and then go to the graph. Now this time we have y equals 2. Notice that if we go down to the graph, then we would have x equals 0, but when x equals to 0, y equals 1, and so x equals 0 wouldn't be the answer. And so having y equals 2, this time we would go horizontally to get to the graph. But when we go to the left, there's nothing on the right hand side. When we go to the left, we hit the graph, and then to read off the x value, we would go to the x-axis. And so it looks like when x equals negative 0.5, y equals 2. And again, this is only an approximate. We estimate that when x equals negative 0.5, y is 2. That is, f of negative 0.5 is roughly 2. Find the domain and the range of the function. To find the domain of the function, we will scan the graph from the left to the right. In this case, what that means is that we're going to scan it from the left-hand side to the right-hand side. The first time we hit the graph, that is where the domains of the graph start. And so the domain of this function starts at x equals negative 1, and it ends at 2.5. Now when we write the domain and the range, we need to pay attention to the open or close interval as well. The domain of the function starts at negative 1 and it ends at 2.5. Now we do want to include negative 1 because of the closed circle at the left end of the graph. And if we want to include it, we would open the interval with a bracket. And we want to exclude 2.5 because the graph ends with an open circle. So to close this interval, we would use the parentheses instead. With the range of the function, we will scan it from the bottom to the top. When we scan from the bottom to the top, the first y value that we hit the graph is y equals negative 1. And then the last y value that we see on the graph is y equals 2. In this case, we include both the left endpoints. Now the domain and the range is also known as the viewing window. Notice that the smallest x values in the domain is -1 and the smallest y value is -1. So we start at -1, -1, and the largest x value in the domain is 2.5 and the largest y value in the range is 2. And so this is pretty much where the graph lives in.